Good afternoon. My name is Perry Heyman. I'm the panel chair for the Ship Warfare System Integration panel. I want to thank you for being here this afternoon and learning about our panel. So the mission of the Ship Warfare panel is to reduce cost, is to work project that will reduce cost and support testing for warfare as well as communication systems, both that support new construction as well as maintenance and modernization. We also, a big responsibility we have is to facilitate communications. We work with Navy programs such as PEO-IWS as well as PEO-C4ISR, and we're here to help foster the communication between ship designers, shipbuilders, and other NSRP panels with organizations that they don't normally get to operate with. It's in modernization. We also, a big responsibility we have is to facilitate communications. We work with Navy programs such as PEO-IWS as well as PEO-C4ISR, and we're here to help foster the communication between ship designers, shipbuilders, and other NSRP panels with organizations that they don't normally get to operate with. So as I said, the benefit for, I'm not going to read these, you can read them as well as I can, but the primary benefit that the Ship Warfare panel gives the Navy and the community is we provide a platform for communication and an opportunity to collaborate where normally we don't have the opportunity. We can start communication with the providers of this combat system and communication equipment and find out common ground, things that we can change either on the shipbuilder side, small changes early in the process for the shipbuilder or early changes for the equipment providers that may have big savings down the road, such as bolt patterns, equipment size, assumptions. So that's the benefit that we provide the Navy. We give the Navy an opportunity and a forum for shipbuilders and these different equipment providers to communicate and look to the future. So we are, as a one of the things that we think we're doing is we're also preparing for the future, right? As you think about the new systems and weapons that are coming out, you hear them in the news and in the press all the time about lasers, rail guns, and things like that. As you start looking at that, the demands on the shipbuilders are going to increase, and we just want to make sure that we're prepared. So we're trying to help foster that communication path, right, with these new systems and these vendors that are coming down the requirement trace, so that we can we can tell them what we have need of and what impacts us, and we can hear from them what they need. So that if we can, as I said earlier, if we can make small changes early in the process that will have big payoff and pay big dividends in the end, that's a win-win for all of us. So we're building these relationships with the OEMs and the shipyards so that as these ties get stronger and the requirements get greater, that we're ready to go and we have create a pathway for this relationship to grow. Since SWISI was started about 5 years or so, we've completed about 14 projects, and we currently have 3 that are in progress of being completed. The majority of those projects that we've done have been focused on physical interfaces. That's one of the challenges we have in shipbuilding is bolt patterns, foundations, and things like that. So we focused on that, on how do we simplify and help to lower the cost. So one of the things that we've done is we've able to help transition technology that was part of the Ford class, and it's currently being installed on LHA and on LPD. And a lot of that, it's called flexible infrastructure. A lot of work was done in NSRP to allow that transition to happen. Currently, we're working a project called POA, or Physical Open Architecture, which is looking at a common rack system that is currently installed on the Ford class. We're looking at how we can extend the requirements from what's on the Ford into DDGs and CGs and other surface combatants. What that's done is it's given us an opportunity to look at how we might be able to use that capability to install it on amphibs. So currently PEO-IWS 10 as well as PEO C5ISR are looking for a common rack solution that they could use to help reduce installation and lifecycle costs. So we see this as an opportunity. We're in discussions with them now on how we can extend this capability. And so far, we think it's very, very promising. So in the meetings that we've had so far, we in-person meetings, we were averaging about 23 people. And we had some before the pandemic. We had some virtual meetings, and we were averaging about 23. But since we went to all virtual, we've been added a few more. We've been averaging about 26 people to our meeting. So I think we are increasing attendance, and people are seeing the benefit of what the panel brings to the shipbuilding and to the communication and warfare system communities. And this shows this also. So overall panel attendance, we've had, after the pandemic, we were averaging about 46 in our meetings. Before, it was about 35. So again, you can see that the attendance is growing in our meetings, and the desire to get involved between the OEMs and the combat system and communication folks with the shipbuilder is of interest. So we're excited about what we're doing, and are excited about the future. So, you know, if there's anybody out there that needs anything in this area, we're glad to help. Go ahead. With that said, if you have any questions, please join us Wednesday at 10 a.m. Eastern Standard Time for our SWISI panel meeting. We're going to have a breakout meeting then, so come, join, and if you have any questions, bring them in. Thank you for your patience and your attention.
Hello everyone, my name is Paul Hebert, and I have the honor of representing the fine members of the Welding Technology panel. Today, I would like to spend some time giving you an overview of our panel and share a little bit about what we've been up to. When you boil it down to its basics, our mission is to improve welding. Most people, when they think about welding, they focus on the actual process itself. But our panel takes a broader view. In addition to the welding process itself, our efforts and interests encompass all of the allied processes, including, but not limited to, those processes that shape and prepare the material, like forming and cutting and cleaning operations, as well as those processes utilized after the welding is complete, like post-weld heat treatment and inspection methods. The central focus of our panel is the development, selection, and execution of research and development. However, let me be clear on this point. Our panel consists of welding technical folks involved in building and repairing ships. We are not interested in R&D simply for the sake of R&D. We are looking for projects that have the strong potential to be implemented in our industry. The overarching and critically essential tool for accomplishing this is through excellent and frequent collaboration. I am both proud and grateful for the opportunity to work closely with welding subject matter experts from all spectrums of the shipbuilding and repair industry. The forum that the welding panel provides for this collaboration ensures that research and development projects that are identified, developed, selected, and executed are aimed squarely at resolving welding challenges, particularly those that are common to many of us, at advancing the technology of an industry that has a lot of room for exciting growth. And finally, improving the cost efficiency of a key but expensive manufacturing process for shipbuilding and repair. So how does the work of the welding technology panel benefit the Navy, as well as the shipbuilding and ship repair industry in general? First, I come back to that concept of collaboration. This time, I capitalized, underlined, and bolded it to stress its benefit. While this one is hard to quantify, do not underestimate its value. What other avenue brings together in one place the welding SMEs from across shipbuilding and repair, supporting industries, academia, and the NAVSEA technical community? The Welding Technology Panel provides an excellent forum for collaboration that opens the door for brainstorming and discussing project ideas that address real-world issues that are common among many of us. Collaboration that fosters professional connections and relationships and the exchange of information. Someone we can pick up the phone and call when we have a question or a problem. The second point I want to make as to how the Welding Technology Panel benefits the Navy is relative to the advancement of technology and implementation. The overall benefits in terms of implementation can't typically be measured one project at a time. That's because advancing the technology of welding is hard. It's challenging and time-consuming. Additionally, the capital investments for implementation are oftentimes significant. That being said, there are numerous welding technologies that are in common use today that we take for granted. But in reality, the Welding Technology Panel played a part in bringing these technologies to fruition. Let's take a moment and look back at a few of the examples. Over the years, the Welding Panel worked several projects pertaining to hybrid laser welding. Today, hybrid laser welding gantries have been installed in several shipyards, and I expect there will be more in the not-too-distant future. The Welding Panel was instrumental in the early development of mechanized welding tractors. Today, all shipyards use these kind of tractors. The Welding Panel worked projects to prove out the weld quality of ceramic backing tape, a simple technology that everyone is using. Over the years, there were several projects paving the way for virtual weld training. Today, most major equipment manufacturers have some version of virtual weld training systems, many of which are seeing increased use today. And finally, let's talk a second about inverter power supplies, which are the standard across the industry. The Welding Panel helped pioneer that technology transition into welding power supplies. Before leaving this slide, let's take a moment and look into the future. Even now, we have several projects that are in the works, and I will cover those in more detail on the next slide, but for now, let's summarize a couple of them. All of us know that additive manufacturing is and will revolutionize the manufacturing of metallic materials and parts. Welding is an integral part of the AM process, and the Welding Technology Panel is and will continue to play a key role in advancing that technology. For example, we recently completed a project looking at a high deposition welding process for additive manufacturing of large parts. We are also working on a couple of projects on hybrid laser arc welding that will further enhance and expand that technology. Okay, now let's get down to the nitty-gritty of what the Welding Technology Panel has been up to since we were in Charleston a couple years ago. We completed a project on high deposition robotic additive manufacturing. This project utilized the tandem gas metal arc welding process, which offers maximum productivity, a 2 to 3 time increase in weld speed and deposition rate for building large shapes. We also completed a project on high penetration dynamic buried arc welding, which is a variation in the GMAW process that results in deeper penetration and enables the completion of a 3/4 inch thick plate in a single pass. This process could realize up to an 80% savings over traditional welding methods. The third project we completed was the development of a weld sequencing modeling software interface, which simplifies the distortion analysis for large structures and thus enabling the optimization of weld sequencing to minimize distortion. The savings in non-value added labor to correct distortion is estimated at up to 30%. We are also currently winding down work on 3 other projects. A project on deep penetration hybrid laser, which couples the hybrid laser with the tandem gas metal arc welding process to expand the thickness range of hybrid laser systems up to 1 inch. This obviously increases welding throughput and minimizes distortion. The next project we are currently working involves monitoring of hybrid laser arc welding. This project uses a laser scanner for in-process monitoring of up to 5 variables. The benefits of this project include improvements in first-time quality, and it opens the door for real-time feedback and process control. Finally, the last project is a testing protocol to establish heat input limits on S1 carbon steels. This project is using a thermomechanical simulator to mimic the thermal cycle of a weld. Using a simulator in lieu of the traditional means of welding test plates significantly shortens the test time and will enable evaluating many grades of carbon steel and develop a maximum allowable heat input. This could eliminate the need for onerous welding procedure qualifications both for the shipyards and their suppliers. The Welding Technology Panel meets twice a year. Our agenda typically consists of a day and a half of technical presentations, accompanied by a half-day tour. In August of 2019, we had an excellent joint panel meeting with Workforce Development at Lincoln Electric in Cleveland, Ohio. As many members of the welding panel sat in the Indian Stadium one evening that week, eating 25-cent hot dogs and drinking beer, none of us envisioned what 2020 had in store. Due to COVID, all of our meetings were held virtually last year. While the virtual meetings were less than ideal, they did enable us to continue with the panel business. I was also encouraged by the level of interest in these meetings, as shown by the attendance graph on this slide. As far as future activities are concerned, funding constraints will impact face-to-face meetings. That being said, and given how much I've emphasized the importance of collaboration, I've been meeting with my panel leadership to discuss viable options to keep the panel marching forward and interest strong. Some of the ideas we are considering include continue to hold virtual meetings. As COVID has taught us in 2020, virtual meetings can be effectively held. We are looking at changing the content of these meetings going forward and focusing on specific topics of interest and crafting an agenda with strong technical presentations in line with that particular topic. We are also looking at the possibility of holding a face-to-face meeting in the fall at no cost to NSRP. And finally, we plan to encourage panel members to participate in other welding events and conferences. For example, in October of this year, there will be an AWS shipbuilding conference in San Diego. If enough panel members show up, we may be able to have an impromptu meeting, maybe even accompanied with a few cold beers, minus the hot dogs. These and other ideas will be discussed in more detail in our Welding Technology Panel meeting tomorrow afternoon. This marks the end of my presentation. Thanks for listening, and I would be happy to answer any questions.
Good afternoon. My name is Orsino Chiara Jr., and I have the honor and pleasure of being the Service Preparation and Coating Panel Chair. Today, we're going to run you through a brief update of the state of the panel and just share with you some of the things we've done, some of the things we plan to do, and where we think we provide a value to the overall process. Service Preparation and Coating Panel mission: specification to deck plate application, a spec to deck approach. We research, evaluate, develop, sustain, current and emerging technology that will reduce costs and maintain or enhance quality in the areas of construction, maintenance, and overall repairs for shipbuilding. Some may say, what do you do? Actually, we engage suppliers, applicators, and specifiers of the preservation system. And in that discussion, we also include Nhrp, that being the tech warrant holder. Offering everyone, why do we do this? We offer everyone a chance to sit at the table. And I mean, everyone, we include everyone. AMP, you may not be aware, but maybe you should be. SSPC and NACE merged last April. As a product of that, the outcome of that merger was AMP, which is the Association of Material Protection and Performance, and which is a tremendous partner for us in this world we live in. Corrosion Community of Practice, which is also a Navy organization, which we play a particular part in. Obviously, Mantech, you're familiar with. Megarush, which we share quite a bit of information with as well. All of those are the reasons why we have that engagement. 2, we facilitate panel meetings, facilities tours, and demos to encourage a broad and active participation. This enables the panel to grow and learn from each other and to walk away with a common understanding of requirements. 3, we network with industry experts. The rationale for doing that to increase the panel and the shipyards and the Navy's overall chances for success. Benefits of the NSRP to the Navy: we provide value from the implementation of our project with a return on investment. That return on investment sometimes is difficult to quantify, but we do think that that return is something that is beneficial, and we utilize our relationship with the tech warrant holder to help in this area. It's a one-stop shop for all issues addressing the industry. Part of the review process for the panel projects include our steering committee, which the tech warrant holder is a member of, and it has a voice for the industry of Navy standards, 00932. That is an annual review that takes place around July timeframe, led by the tech warrant holder, with the overall coding community, meaning suppliers, shipyards, as well as multiple other organizations. And actually, NSRP coding panel is given 2 invites to that because of what values we bring to the table. And a lot of times the panel brings actually standard items that have been reviewed internal to the panel that we think that need to be reviewed or changed or enhanced that will help our shipbuilding community moving forward. We've been very successful in that arena. Vendors, suppliers, having those vendors in place, understanding customer supplier requirements. When we have these projects, we have our suppliers on board with us. Many times the team members, so if we have a issue relative to a coatings, or we have a need for a particular improvement in a coatings, when we have those individuals on board, we have a chance to be successful. Participate in shipyards. What it does for those shipyards, provide funding to look at issues that you have you've been trying to resolve, but you may not have the funds or the resources to do internally. It allows you to network your counterparts and your interaction with the Navy representative. And associate with academia. When necessary, we pull on those organizations to help us. There's a lot of things that doing with NSRP that you can see through Penn State. There's a lot of things that done through the AMP organization with Texas A&M, and we pulled in community college to help many projects we're doing. The list, this is a laundry list, actually of 18 projects that have been approved for funding from 2014 until 2020. These projects were all initiated during the current administration time period. They show many things that we've done and how we think we provide value to the government. We're going to talk a little bit more about a couple of items for us familiar with how you go from people plus processes equal performance, and some of the things we're doing to ensure our people have the resources for being successful, and some of the things we're doing to improve those processes as we move along. A couple of past projects. These focus on the people. There was a certification program for shipbuilding. Far as going in and saying, okay, there is a need to continue to improve the education, knowledge, and welfare of our shipbuilders. That being the case, we want to make sure that we, as an organization, provide some of those tools. We found out over the past few years that, because of the limited resources in this arena, as you get qualified and trained people up internally, there becomes competition between the shipyards and the contractors for their services. We want to make sure that we have adequate training across the board, or at least have a vehicle in place to improve that for our people. Some of the benefits of that would increase quality performance, improve EH&S, environmental health and safety performance, due to increased coatings knowledge. You know, I tell internal to Newport News, I tell the environmental organization that we're the greatest customer because we can create problems for them. But if we continue to improve and grow as an organization, become more knowledgeable, we can also prove to be an asset to them for not having things that go wrong, proving that we are part of the big team, part of the overall success factors, and possible cost reduction in a very labor-intensive environment. Virtual sprays, another one. We're looking at people. Actually, it's interesting. We're doing this project now that we're living in this virtual world. What it does, it provides the actual sprayer with the ability to go in to a compartment, do the use of this virtual system, and learn how to spray in tight components, learn how to spray consistently, and make sure he comes out once and he's done. What it does, you know, so when he's over, he sits down with the instructor and go through what he did well, what he didn't do well, and how he can get better. Potential savings to the Navy is increased quality performance as well. Potential material savings because you're not wasting paint in some areas. Potential long-term, maybe enhance your schedule performance, and possible overall cost savings. Some of the current projects that we're doing talks more along the lines of processes. So we say we want to look at people, ensuring they have the resources and tools to do their job, and look at processes. And those two things combined, enhancements in those two areas, will allow us to do better on our performance. Surveys of survey preparation and coatings automation. We have taken an effort to go out and look at, say, what are we doing from an automation standpoint internal to the coatings arena? What are we doing external to the coating arena, and what can we learn from others? Can we go into the automotive world and see what they're doing and try to take advantage of those? Can we close the gap on the automation things we're doing internal to shipyard that may not be coating related, but may be applicable to coating? Obviously, the value to the Navy is a possible cost reduction. Like I say, coating is a very labor-intensive environment, and if we can find some ways to remove some of those labor-intensive efforts away from our people, they will stay healthier, and we'll have a smoother process. Standardization, digitalization of visual inspection. We capture data electronically, efficiently report data without duplication of efforts, and it has immediate access for that is consistent, objective, and clean. This provides to the Navy less touch time or manual data entry, increased record accuracy, because if you have coatings records, which you have to trace throughout the life of the ship, and if you're looking at an aircraft carrier, you may take 7 years. That's a lot of records for a very large vessel that potentially can create problems for people doing duplicate efforts and potentially even loss of data records. And a clean handoff to the Navy. With this system, what it allows us to do, we can actually hand the Navy, or we can send them a document or an email, so to speak, or we can give them a pile of paper. We prefer to give them something that is more like paperless. Optimized power tool surface prep. You know, obviously there's a lot of tools that are utilized within the coatings arena to do a surface preparation. We want to understand what those tools are, understand how effective those tools are, and for what particular application, and then limit what we do. Actually take some things away. Don't just because there's a tool out there that says a power tool, that you give it to an individual. No, give them the right tool for doing the job. And that will create an environment in which you have the appropriate equipment inside your shipyard. You have your people internal from a maintenance perspective that can keep those things up, and you're not having to keep up with 1,000 different variations for something of this nature. Potential savings to the Navy is guidance on how to optimize power tools, and improvement in quality and possible cost reduction. One of the things that have gone on over the past few years is actually seeing, you know, how do we continue to compete or keep people informed during the pandemic and in the virtual world. We've always had an opportunity to do things virtually. We've always had some challenges prior to the pandemic. I would tell you now, the pandemic has given us an opportunity to be more successful in the virtual world, and the coatings arenas are still doing those things with people. We've had quite a bit of increase. The number I always thought about was around 50, and now it shows 57 and 49 prior to, so that gets me to around 50 point. But what it really shows, the fact that what you miss here is the fact that you do not have that time for those one-on-one interaction. I understand that safety comes first. That is our primary concern. We want to ensure that our people are safe. We do not want to put anyone in harm's way, but when we get to a point and we may never be the same that we was previously. But when we get to a point where we have is a safe for us to potentially meet face to face, there are certain advantages to that, and we try to take advantage of those things. The next potential opportunity for that is actually Mega Rush is slated to meet in September of this year. It actually says it's a face-to-face meeting. I think they give you the option of virtual as well. It's going to be in the Hampton Roads area. So plenty more to come there. We'll keep you informed as we move forward. So, it's tough to give you a potential total overview of everything we're doing in coatings arenas only in a 10-minute time frame. I would like to let you know that the 3 projects we talked about our current projects are slated to be reviewed during our all-panel breakouts. Surface preparation and coating panel breakout session on Thursday morning, starting at 10. May run a little long. We got a lot of things to discuss, and that's one of those things like having your personal time. But we'll do a good job there. We always close with this a couple of comments from me, but the items I wanted you to be truly remember here is the fact that, remember, the work isn't complete until the ship is painted and or cleaned if you're using polysiloxane, and the coating system is documented, preferably paperless. Thank you for your time. I look forward to you joining us on Thursday, where we should be in a position to address your question. Have a good day. Enjoy the virtual world, and we'll see you very soon face to face. Thank you.
Thank you, Q, and thank you, panel leadership, for providing those updates. Next up will be updates from the Centers of Excellence for the Navy Mantech program. First up will be Mr. Tim Baer. He's the director of the Institute for Manufacturing and Sustainment Technologies, operated by Penn State ARL. Tim.
Hi to everyone attending this year's virtual NSRP all-panel meeting. I am Tim Baer, Director of the Institute for Manufacturing and Sustainment Technologies, the Navy Mantech Center of Excellence here at ARL Penn State. I'd like to spend the next couple minutes introducing you to ARL and IMAS, tell you a little bit about the technology areas that we concentrate in, spend a little bit of time telling you about the staff of IMAS and ARL, and then go into a little bit of detail talking about the projects that we have successfully executed or nearly finished on since your last NSRP all-panel meeting. Now, to say the least, and I took this video outside intentionally to convince you that I really mean it when I say I wish we could be doing this in Charleston this spring. We very much would like to see a little bit of spring here in Pennsylvania. To say the least, the groundhog was right. So without further ado, I'm going to go ahead and transition now to talking over the slides that I prepared for you today. Okay, jumping past the introductory slide and my contact information, I'd like to tell you a little bit about the Institute for Manufacturing and Sustainment Technologies. We were first established in 1995 officially as one of the Navy Mantech Centers of Excellence, having supported the Navy Mantech program unofficially for several years before that. We're located, as I'd mentioned before, at the Applied Research Lab of Penn State, which is one of the Navy-sponsored university-affiliated research centers. So we're a trusted agent as established by OSD and dedicated to support DoD in our charter areas, which I'll go into minor detail later. IMAS supports the mission areas of the Mantech effort in manufacturing technology, repair technology, as well as capability acceleration, as described by Neil earlier. The details on IMAS technical area of concentration really are not limited. We can work in almost any of the technology domains that ARL represents. And so my parent organization, as a matrix, IMAS has as its workforce any of the 1,300 full-time research engineers, scientists, and staff that support the Applied Research Lab. And below on there, in the bottom bullet, you see a little, very, very brief description of the technology areas that ARL concentrates within. Moving on to slide 4 and the key staff, as I'd mentioned a minute ago, we're a matrix organization. Consequently, all of my projects are executed by ARL staff. We don't have any principal investigators, research engineers on the staff of IMAS. If you have anything that you would like to let my boss know in terms of complimentary and positive feedback on the IMAS program, there's his contact information below. And I would like to now transition into a little bit of a description of some of the projects that ARL IMAST has completed successfully over the last couple of years since your last all-panel meeting. The titles in purple that you'll see on these quad charts are projects that are going to be briefed to one of your panel meetings. The next slide, slide 6, is entitled Sustainment. The top half of that slide, those two projects, are both completed and successfully implemented. The first one, False Deck, was a collaboration with CMTC and working with Bath Iron Works, Newport News, as well as Ingalls to develop and get approved through the formal technical warrant system a new deck material that can replace the old unreliable decking that has been used in some of those spaces. Dual Track was a RepTech project we did first with Puget Sound, and upon successful completion of that submarine coating removal project, we helped the other 3 shipyards get systems for their use on submarine coating removal processes. Bottom 2 are also RepTech projects in support of IWS Crane. And in each of those, we're looking at technologies to help in the overhaul process for those radar slats and to improve their reliability, time on the ship, if you will, and new technologies that might improve their sustainability, such as laser ablation for those aluminum slats, and the exploration of passivation as a method to eliminate, at the minimum, the hexavalent chrome that's being used. And potentially, we think, as this project concludes here in the next month, we'll see an expansion of that technology to support other structural aluminum being used within the Navy. On slide 7, facility sustainment, are 2 projects that we're using our expertise in condition-based maintenance to support the facilities in improving their reliability, decreasing the incidence of catastrophic failure of critical systems, and in the case of rate, which is support of the F-35 and Northrop Grumman, to improve production quality using censored systems and the Internet of Things to let the parent industry know when quality is beginning to degrade. On slide 8, under materials and manufacturing, 2 projects that are completed and 2 that are still active. Ball valve was completed this past summer and is in the process of being approved by the technical warrant community, as well as changes to drawings made between Electric Boat and PMS 450. That project is complete. It was successful, and the outcome was 2 new coatings that will significantly reduce the incidence of new manufacturer rejection of those ball valve balls. Improved low-loss launch valve in support of NavAir and Lakehurst in support of the carrier program's launch equipment is using a new technology to expand the thickness of the bond coat and wear coat that, when failed, creates a catastrophic failure of the launch system and a shutdown of that catapult. Laser ablation of coating debris is back up and running in the very near future, and we'll be using that project not only to improve panel line efficiency and reduce the incidence of hazard to the workers there, but expand the applications of laser ablation in shipbuilding and ship maintenance. And finally, retractable bow plane ended a couple years ago, but we've expanded the applications now to include both the Virginia-class program and the Seawolf program. On slide 9, under metals, you'll be getting a briefing later on portable hatchable cold spray, actually an update on the state of transition of cold spray technology in general, in support of both new manufacture and sustainment. This system that was this project, which was successfully completed last spring, is going to provide the opportunity for you to take cold spray to the part in situ within the ship, as opposed to the current state, which is to require the cutout of that material, that component, and delivery to the shop for repair. The other two projects on the right, both concluded cold spray projects that we did in support of Navc and IWS. I might add that as a result of those two projects, we now see the application or implementation of cold spray in all of the Navy sustainment enterprise, Marine Corps, NAVAIR, and NAVC. And finally, I think you're all aware that ARL is a giant in the additive manufacturing world. In this project in the bottom left, we are using additive manufacturing as a capability to repair components that are currently obsolete in support of the AV8. The last slide, slide 10, under Advanced Manufacturing Enterprise, I think a lot of you are familiar with the projects we have successfully completed, some of which were collaborations with Ncm or its predecessor. And in those projects, we are seeing the incorporation of efficiency-based modeling and simulation, capacity planning, decision support, scheduling, those kind of projects that are being widely implemented across the shipbuilding enterprises, and of late to include both the ship maintenance at Puget Sound and the submarine factory, as well as Albany Marine Corps base, and to support the Marine Corps depot there. PBOM on the bottom right is the first use of AI that will be implemented. It is implementing at Bath Iron Works very successfully, and that project will be concluding here next month, and we'll give a follow-up report on its success at a future date of your convenience. So finally, there's our contact information. If you'd like to reach out, let me know. I would love to talk to you, give you a little more detail, and put you in touch with the PI on any of those projects you might be interested in. And I hope you enjoy the rest of the NSRP all-panel meeting. Thank you.
Hi, good afternoon, folks. My name is Tommy Gill. I'm the director of the Electronics Manufacturing Productivity Facility. We are a proud ONR Center of Excellence and ONR's execution agent for all things under the electronics manufacturing technology domain. I'm going to talk to you a bit this morning about what we are involved in and what we actually do in terms of actionable projects. And let me begin by just talking a bit about our mission. What we do here at the EMPF is similar to what all other COEs do. We identify, develop, and basically facilitate the transition of electronic manufacturing technologies for multiple goals, primarily for affordability-based goals that reduce the cost of both affordability for acquisition as well as in-service maintainability, RMA. We also perform projects or execute projects that are designed specifically to dramatically and quantifiably reduce the amount of time between design, development, and ultimately fielding of those capabilities to the warfighter, which is obviously a very important consideration right now within DoD and certainly the Navy as well. Below in this chart, you'll see a variety of technology areas that we're associated with. And what you'll notice about electronics is that it's a very high, wide, and deep area. We are involved in a variety of things, not only circuit-based, but also material science, physics, and other supporting technologies. Primarily, starting with number one, we are electronics manufacturing technology based. We develop innovative technologies to meet downstream Navy and DoD requirements. We look downstream in a more strategic way so that we are able to understand Navy and DoD requirements over the next 5 to 7 years and make sure that we have those capabilities available to fulfill those requirements. But we're also involved in an awful lot of supporting technology areas. For instance, gallium nitride, wide bandgap semiconductors are a particular area of interest for us. We've done an awful lot of work in other semiconductor-based technologies. All things integrated circuit, which have really progressed over the last 45 to 50 years, from very, very large form factors to very, very small form factors, on chip-based technologies. Interconnections might not seem particularly relevant, but they're very relevant actually, and we're involved now in additive manufacturing technologies to improve the reliability of interconnections, particularly at high frequencies. We do an awful lot of low-cost based, high-throughput manufacturing. We have a full-fledged support element on our manufacturing shop floor that allows us not only to do prototyping for electronics, but also rate-based manufacturing to support electronics work for DoD concerns as well. We're involved in a variety of other areas. Thermal management is one I would really like to highlight because almost every project that we execute for Navy or DoD has some element of thermal management associated with it. And this is particularly true when you're getting up into your higher power and higher frequency applications, which we're seeing more and more of for Navy surface combatants, for instance. Micro electromechanical systems, very sophisticated systems for sensors the size of a postage stamp or smaller. We're involved in energy storage. We have significant expertise in battery storage devices, and we're working those actively for the Navy right now. Microwave, COTS integration, open architecture. One of the things that I'm particularly proud that we're involved in, and it's somewhat novel, is supply chain integrity. As you look down at the vendors that support your supply chain, what we're able to do is to make a very, very detailed assessment of that supply chain and find ways to mitigate risk and bolster the supply chain to maintain a robust supply chain structure over the life of a particular project. An awful lot of detection for counterfeit parts, which is particularly topical right now in our industry. And of course, at the end of the day, a lot of what we do boils down to system engineering. So not only do we have very specific expertise in particular technologies, we also have a much more system or holistic based view of how those technologies are brought together and ultimately fashioned into something that can be utilized by the warfighter. So what do we actually do here? We've talked about the technology domains that we're involved in. What do we actually do that's actionable in terms of project execution? I would say probably first and foremost, what we do is we apply our expertise toward electronic packaging. A great number of the circuit boards that we design or innovate or augment have to be packaged in such a way to withstand a very hostile end-use environment. And so a lot of our expertise goes to that regardless of what the end use of that's going to be. We're also very, very proficient and do an awful lot of work in design engineering across the three major areas of electrical engineering, which are radio frequency, analog, and of course digital. People are sometimes surprised at the amount of material science that goes into what we do. It's not just a cadre of electrical engineers. We also have significant expertise in engineering materials because material science is really one of the major things that's driving our particular technology envelope. Power electronics and semiconductors, of course, particularly those that are supporting higher frequency applications. We also do a great deal of sophisticated and, to use an overused term, state-of-the-art based, model-based design. We use something called COMSOL, which is a physics of failure platform that allows us to concurrently analyze structural elements, fluid elements, thermal elements in such a way that it gives us a much more holistic understanding of what we're designing and provides a better path forward. As I already mentioned, we do an awful lot of thermal design analysis and test to make sure that whatever we produce is going to be thermally capable in the field and not overheat. We, of course, are also involved in prototype development, but also in actual production. We do a fair amount of production work here based on our extensive full-fledged shop floor capabilities and resources. We also have a full-fledged analysis lab that involves chemical, X-ray, both destructive and non-destructive testing to ensure our end customer that what we make is a quality product. And last but certainly not least, we provide a full array of training capabilities and services across the board at the technician level, operator level, engineering level, and even at the manager leadership level. So anywhere from a single operator on a particular shop floor function all the way up to somebody who's going to be presiding over and managing an entire electronic manufacturing facility. We also do quite a bit of custom manufacturing training for our end-use customers, both in industries such as the Lockheeds and Raytheons, as well as our government customers, which would include certainly the Navy and the Army as well. Our key staff members, Alan Criswell is the president of the company. He stood the company up in 1992. He is a former ONR program officer himself for Mantech. And the company was basically developed on the notion, with the premise in mind rather, of bridging the gap between technology developed in the laboratory and actually getting that technology fielded across the Valley of Death. We've been working that same mission for Mantech now for almost 30 years. Dave Hughes is our ACI Director of Finances and Contracts. I am the Director of the actual EMPF, Center of Excellence. Carmine Miola is our Technical Director, who is very capable with almost 40 years of experience. And if you look at our talent pool, it's not just electrical engineers, it's a wide cross-section of cross-disciplinary expertise, starting with electronics and electrical engineers, but also including applied physics, mechanical engineering, manufacturing specialists, of course, and also material scientists. So collectively, it's a very broad area, much broader than just electrical engineering itself. What are some of the things that we've done to over our lifetime as a execution agent for ONR? One of the more recent ones we did that dramatically benefits the surface warfare community is an open and common modular building blocks project to enable affordable radars, and not just one affordable radar, but this project really was generic in the sense that the outcome provides a way forward to also apply to not only the surface radar that we actually developed this for, which was Navy Next Generation Surface Search Radar, but also a plethora of other digital radar systems in the future. The project premises was based on the fact that the most expensive and unreliable components of a radar generally are the power tubes and high voltage power supplies. These are designs that are almost always highly tailored to the particular radar system and mission application. So what this project did was we utilized commercial off-the-shelf technology in a very open architecture fashion to develop solid-state replacements for those legacy components that will be much more reliable, much more affordable, and provide much greater maintainability savings over the in-service life of the radar systems. Project benefits, combined acquisition and in-service, amount to about $90 million over at least 200 hulls. The actual innovation, of course, was the solid-state replacement for these tube components, but the insertion goes into a new radar system, which, as I referenced, NGSSR, which is going to be integrated into most every surface combatant of the Navy in the coming years. The first insertion is scheduled for May of this year, and it will continue through over the next 6 years and beyond. And so we're very excited to be part of this. We're very energized by what was accomplished, and we look forward to leveraging what was done on this project with hopefully other future projects downstream. Any more information? I welcome any comments or questions you might have. Please feel free to reach out to me or anyone else in our organization, and I look forward to talking to you. Thank you so much.
Hi, I'm Andy Tregesser. I am the director of the Electro-Optics Mantech Center for Navy Mantech. And I'm sure some of you are wondering, who is this Rube and where is Dave Ditto? So yes, it's true. After 20 years of service with the EOC, Dave Ditto has decided to retire at the end of April. So I have a slide on that coming up and hope you'll get a chance to write him an email of congratulations. So I'd like to explain what the Electro-Optics Center does for shipbuilding and who we are and some example projects of how we're working within ships. The Electro-Optics Center is a part of the Penn State Applied Research Laboratory. It operates within the EO division of Penn State ARL. And we've been a Mantech Center of Excellence since 1999. So for 22 years, we've been located in the suburban Pittsburgh area in Freeport, not in State College, but just a couple hours drive. And our mission, and this is a hefty one, but our mission is to transition new electro-optics technologies and applications to Navy selected focus platforms through strong technical interactions with DoD and its industrial base, demonstrating acquisition cost savings, lifecycle cost savings, and accelerating capabilities to the warfighter. That is a mouthful. That's a large mission, not something that you'd want to be able to put on a t-shirt, but it gives us a lot of opportunities for different ways that we can affect getting electro-optics technologies to the warfighter. So let me talk about the technical areas that we work in the Electro-Optics Center. And I'd like to differentiate between manufacturing of electro-optics and the manufacturing using electro-optics. So first, with manufacturing of electro-optics, these are things like making a laser or making a new kind of camera, optics in windows, electronics materials, interconnects, fiber optics, all those kinds of things that build up into the systems that you might find on a ship, like a photonic mast or tracking systems, or the lighting, remote source lighting in some cases, or laser weapons, as we'll see in the next slide coming up. And that's differentiated with manufacturing using electro-optics. And here we take all the tools of the trade in the EO, looking at cameras and sensors and lasers, and you think about how ubiquitous they are in manufacturing environments today. So we get involved with metrology and inspection, vision systems, augmented reality, new kinds of sensor techniques, and drone and robotics applications, because those are also very sensors based and require those kinds of applications. Of course, the third leg of the stool, common to many of the sister Mantech centers, is supply chain analysis, modeling and simulation, risk management, industrial base assessments, all those things that are germane to putting together a good manufacturing platform, in our case, for electro-optics. The key staff for our center, and I list Dave Ditto first in homage to our retiring director, so I'm listing him as the Director Emeritus, and I've got his email address there if you want to drop him an email of congratulations, and I hope you can. We also have a new technical director, just new this year, is Rob Sobek, joined us last summer, and Tim Kennedy is our project manager, and you may have, if you've worked on projects with us in the past, you may know Melissa and Anissa working in contracts management, and Chrissy Spihar does a lot of interactions with O&R, making sure that our financial picture is sound. The principal investigators listed below that are people that you might be familiar with, Ken Freivogel, Jason Hunnell, Jim West, people that have different areas of specialty within electro-optics, and they'll pick up and run different kinds of projects depending on the type of project that it is. So let me talk about several projects of, I'll start with manufacturing of electro-optics. And so laser weapons are a new kind of tool that is here for the warfighter, just getting to be a program of record, and you may see it on some of the focus platforms that we have for Navy Mantech in the next few years. So in order to get a jump start on that, we need to accelerate that capability and have that those types of systems be manufacturable in a repeated way and not just made in a one-at-a-time recipe. So we have some baseline projects of just looking at what is the right powder for making spinel to go into a window that covers the end of the laser weapon. There are very high levels of optical power that goes through these windows. They have to be of very high quality. We have to be able to make them repeatedly. So that's just one example of the kinds of tools that need to go into a new class of asset like this that's going onto ships. And there are many such projects like that that we'll take on presently, like the 4 that you see here, and then also in the future, in order to really get at the production rate, the quality, and reducing the life cycle costs of having an asset like this on a ship. The next project I'll talk about is fiber optic links and testing. This is test adapter efficiency improvement. This is really a project that goes in line with the ILTS, or Integrated Link Test System. And this is a project that will be presented in depth at the electrical panel session. And so check out John Mazurowski and Jason Farmer, who can give you more of the details on this. But we took on being able to measure not just the fiber optic links, but measuring the electrical links, RF, and the fiber optics, putting that all in one kind of box with many different types of adapters in order to switch out. And we ended up using 3D printing for that. OTDR is in play for measuring the fiber optics. That's the optical time domain reflectometry. And this box, as you'll see in the picture below, is now made at less than half the weight and half the size of the original ILTS, and that was picked up by our commercialization partner, Ditmaco, who brought this one across the finish line even as the project was concluding. So we're looking at a potential cost savings once implemented of $742,000 per DDG. The next project I have is moving more toward electro-optics as a tool for manufacturing rather than manufacturing of electro-optics. And so the first one I'll have here is tank inspection using drones. And so you can start to get a feel for the type of challenge, the technical challenge that we take on with the projects that we'll do. Not just using a drone for taking pictures, but using a drone to go through a hole that's only this big, where it's difficult for a person to get in there with a camera, and it's a very difficult kind of inspection, a dangerous inspection. And to be able to do that with a drone presents lots of good possibilities for us to be able to get pathways for many different types of inspections, not just an optical inspection, but putting essentially a sensor on the drone that would be able to do many different kinds of things. So we're looking at that right now, and this gives us not only a better occupational health and safety performance, saving time of not having to put people in that kind of environment, but also supporting transition to digital inspection processes, very good record keeping, because we can get the data on the fly and get it to the right spot. So through that, we get an increased accuracy. So there's many different types of drones that we could use. We have to have something that fits in the right spot, small enough and yet large enough to carry the payload, and it has to be able to navigate through all these twisty little passages inside a tank. Very challenging project, and we welcome the building or purchase, whatever it may be, as this project matures. And then the last project I have is automated metrology for structural assembly, also a very challenging project. And so in this one, we're putting together large ship sections. They might be 40 or 50 feet long. Think of it as a single deck system. And sorry, the picture, this distro A picture that I have has partial outfitting in it, but you get the idea. If we have to measure something like that and say, over this very large section, is it ready for joining? And we don't want to we want the ease of not having a surveyor crew coming in to do a bunch of measurements, or getting a person to pan through all those measurements and see what it is that, whether they're ready to weld or not in this case. Very challenging to make that a totally automated process. So we'll have at the end of this project, we hope to have a heat map of deviations from a large standoff distance. And if the standoff distance is too long, we can do the setup. We can do this job with very few setups, either with, it might be laser scanners, it might be laser trackers. I can almost give you a spoiler alert, it won't be LiDAR. And photogrammetry looks very promising in this case. But looking at the number of setups, the obliqueness of the angle of what you're measuring creates a lot of range error in this case, and just very slight perturbations in the pose of the sensor that you're using can cause those kinds of deviations. So we think this is a very valuable piece of research and hope that we can get considerable cost savings out of that. So I hope you've had a chance to just see the kinds of different projects that we've been involved with in the Electro-Optics Center. If you want to learn more about it, drop me an email, check out our website, and I hope to be able to talk to you about future kinds of challenges that we would have using electro-optics. Thank you.
Hello, Navy community. I'm Mark Snyder, the Deputy Director of the Center for Naval Metalworking, based out of Summerville, South Carolina. While I wish we were all together in our normal environment for the NSRP All Panel at the Francis Marion Hotel in downtown Charleston, I appreciate your time today and hope all is well on your end. Rest assured I'll be making my way down there this week to have a few oysters and a beverage or two on your behalf. Similar to the other ATI-managed Navy Mantech Centers of Excellence, CMTC and Ncm, we leverage a virtual COE model. However, Cnm is unique in that it employs a hybrid approach through a strategic partnership with EWI out of Columbus, Ohio, a world leader in manufacturing technologies including additive manufacturing, welding and joining, ND inspection, among others, to provide further depth and subject matter expertise in project performance in order to derive state-of-the-art solutions from the best available sources to implementation on our target Navy platforms. Led by our program manager at O&R, Neil Graff, Cnm is comprised of professionals with a broad blend of technical capabilities, management skills, and practical experience relevant to our research focus areas, which I'll cover more in depth in a few slides. The Cnm Leadership Team, starting with our Executive Director, Marty Ryan, has led Navy Mantech Centers for over 15 years, while our Tech Director, Paul Blomquist from EWI, has over 40 years of experience in DoD metalworking. Our Contracts Manager, Skip Solis, has over 35 years of government contracting experience spanning active duty, civilian, and industry positions. Additionally, I've now served in the role of Deputy Director for the last year and a half and have an additional 13 years of experience working with and managing metalworking technologies for a variety of military applications and services. Our research network of industry partners, DoD shipbuilding and aerospace OEMs, university partners, and technology providers are at the center of the organization. As previously mentioned, employing a virtual model allows us to reach out to the U.S. industrial base to formulate teams that are best suited to meet the Navy's manufacturing challenges on a project-by-project basis. As a result of our proven COE structure, strong partnership with platform OEMs, and collaboration with key program offices, we're currently projecting over $430 million in Navy cost savings just on our completed and active projects, which we anticipate will grow significantly when we start to take into account the savings attributed to the additional projects we have in development. Slide 5 provides an overview of our research focus areas across the Navy metalworking domain, which includes additive manufacturing, industrial base infrastructure, joining techniques, materials characteristics and testings, metals and advanced metallic materials, process design control, and surface and heat treatments. As you can see from the chart in the lower right portion of the slide, which is reflective of our completed, active, and in development projects, we currently have a fairly diverse project portfolio across the technology areas. Now I'd like to take some time to highlight a few of our completed and ongoing projects. The first one being optimal methods for installing machinery foundations on surface ships. This is a completed project with Ingalls Shipbuilding to develop more efficient and cost-effective methodologies across fabrication, outfitting, and shipboard integration of machinery foundations. The resulting methodologies have been implemented on LHAs and LPD ships and is currently being phased into the DDG construction at Ingalls facility in Pascagoula, Mississippi, culminating in a total savings of $830K over 5 years. The next project, Automated Pipe Fitting Scriber with Bath Iron Works and EWI, as you may infer from the project title, is focused on developing an automated pipe fitting scribing unit to replace the manual methods currently employed at the shipyards. As most of you are aware or can imagine, there are thousands of welded pipe joints across multiple systems and sizes on any given class of ship. In order to meet build specification, a scribe line at a specified distance is required for each intersection of a pipe joint. Currently, BIW primarily uses a white heat-resistant pencil to manually mark the fittings. While adequate, it does have limitations on resiliency, and the marks are easily removed during pre- and post-weld cleaning. Ultimately, this can lead to the joints needing to be recut and refit if they cannot be identified during visual inspection. Upon a thorough industry canvassing exercise and instruction selection process, MECO was chosen as the prototype provider, which has just completed shipyard acceptance testings at BIW a few weeks ago. The new unit can scribe tees, reducers, couplings, 45 and 90 degree elbows from half-inch to 10-inch in pipe sizes. This is anticipated to generate $2.2 million in cost savings at BIW on the DDG-51 platform. I also wanted to highlight that the team of ATI, BIW, EWI, and MECO have executed the project exclusively remotely without a single in-person meeting due to COVID-19 restrictions and is on track for a successful conclusion next month. The Newport News Shipbuilding Foundry Casting Improvement Project, currently ongoing, is working to investigate and implement a method to protect the molten metal as it flows from the ladle into the mold. Previous investigations at Newport News have found that the majority of the defects they see in their foundry are at the surface or slightly subsurface location, which are primarily Siroxide related, per research conducted by the Steel Foundry Society of America. The principal approach the team is taking is to develop a shroud and tundish design to isolate the molten metal. The team will leverage expertise at the University of Iowa and ESI to develop simulations and to design and optimize the shroud and tundish. Test castings with the current methodology will then be compared against the optimized shroud and tundish design to determine the reduction defects in the quality of the pour, which is predicted to save $6.5 million over a 5-year period. The next project I'd like to highlight is the portable welding robot project at Electric Boat. The project team also includes EWI and recently identified ARC Specialties as the robotic integrator. The project is focused on developing a mobile robotic welding system that can be easily moved throughout the fabrication facilities versus bringing large submarine assemblies to a stationary welding cell or system. The project anticipates providing nearly $10 million in cost savings over a 5-year period. The shaped plate automation project at Ingalls Shipbuilding aims to reduce the manual labor required in shaping and verifying shell plates through automated processes. The current process is very labor intensive and requires a highly trained workforce, as you can see from the images on the right. The team, which includes EWI, CTC, and ARC Specialties, is investigating the optimal software and hardware systems to automate the plate shaping and verification, developing a prototype system to evaluate, as well as a prototype pin jig fixture and verification methods for positioning shell plates. When successful, the results will be a dramatic advancement over the current techniques, culminating in over $9 million in savings over a 5-year period. I hope that the select projects highlighted today give you a flavor for the type of projects and technologies we're focused on at Cnm, with the ultimate objective of reducing material acquisition, maintenance, and repair cost of current and future Navy platforms. I appreciate you taking the time today to learn a little bit more about the Center for Naval Metalworking. If you have any questions or feel like your organization has a good idea for a Mantech project, I encourage you to reach out and contact me. We would love to hear from you. Stay safe and have a great rest of your day.
Hello, I am John Osborne, Executive Director of the Composite Manufacturing Technology Center. This presentation will provide background information on CMTC, walk through a few recent successes implementing composites on ships, and cover the best areas to use composites for ship applications. Our mission at CMTC is to identify, develop, and deploy advanced composite manufacturing technologies that will reduce the cost, time to build and repair, and/or increase performance of Navy platforms. We execute the center using a virtual model, which we believe delivers the best value to the government by teaming with the best available resources, pulling in state-of-the-art capabilities, and incorporating emerging technologies from labs and technology programs such as Future Naval Capabilities, all in an effort to drive enhancements and cost savings to benefit our warfighters in as broad of a way as possible. The Office of Naval Research funds CMTC as part of Navy Mantech. As I mentioned, I am the Executive Director, Nick Melillo serves as the Technical Director, and Ryan Frankert is our Deputy Director. Skip Solis is the Primary Contracts Manager for most projects, and Melissa Frady is our Business Manager. We have 4 project managers, Leslie Hill, Robert Santiago, Josh Marion, and DeAndre Cherry. We have a number of consultants we tap into for specific technology needs, and consistent with our virtual model, we pull in resources as needed from our industrial partners, other centers of excellence, universities, and other government resources to build our project teams. Over the last 21 years, CMTC has transitioned more than 80% of the project started. We believe that is the correct transition percentage for composite technologies, providing a balanced portfolio of high-risk, high-reward efforts, and some moderate to low-risk projects with moderate rewards. That implementation rate corresponds to an overall return on investment of greater than 9-to-1 and a total lifecycle and acquisition savings of $1.43 billion. We currently have 14 active projects with over 30 in development. On the left, you can see the logos owned by the program offices, and on the right, you can see the logos owned by the industrial original equipment manufacturers currently targeted by the ONR Mantech acquisition strategy. CMTC's research focus areas fall into 4 major topic areas. Composite and advanced materials include fiber reinforcement structures, matrix materials, engineered plastics, and coating materials, or more basically, of what a composite system is composed. Complex structure and design includes internal and external stiffening systems, materials for radomes and electrical applications, foams and other shaping materials, and bonding technologies. This focus area is more basically how the system is engineered to interface with the surrounding structures. The third focus area is testing and inspection to include standard destructive testing, non-destructive evaluation, and modeling and simulation. This focus area validates the composite system will function as intended for its service life, which in the case of ship-based designs can be the life of the ship. The final focus area is processing and automation to include robotics, additive manufacturing, post-processing, or more simply, how the composite system is made. As you can see, we have a wide variety of focus areas to address a wide variety of warfighter needs. Manufacturing for submarines offers a unique challenge, but also an ideal environment to make elegant use of the benefits a composite system offers. Nearly all systems have a doubly curved shape, which are more expensive to fabricate out of steel and less repeatable than molding a composite. Additionally, most everything spends its life below the waterline in a corrosive environment where steel requires frequent painting, repair, or replacement. Composites can last the life of the ship without the need to even paint. CMTC coordinated with NAVSEA CL Cost Reduction Program and later the VPM Expansion Program to implement a variety of individual pieces on the sail, which we then leverage those lessons learned to the VPM topside structure. We have saved over $200 million for the VCS program in lifecycle and acquisition costs. Additionally, those lessons learned were leveraged forward to the Columbia-class submarine during the design phase, which is the best time to consider composite materials and systems. The Noca Decoy composite canister is an example of a Mantech project that impacts multiple ship platforms and incorporates a multi-purpose system to include static corrosion resistance to saltwater environments and EMI shielding to protect the decoy. The project team had to interface with the existing system design by maintaining the form, fit, and function for all platforms. The technology had to be applicable for both new and retrofit canisters, and they had to improve the reliability, life cycle duration, and cost of the canister. The most important aspect of this system is the assurance that the decoy will deploy when it is needed to save the lives of every sailor on the ship. The resulting canister is lighter, cheaper, and has a service life 4 times that of the existing aluminum system, saving $12 million for an ROI of 55-to-1. The false deck project leveraged early Mantech work that improved the processing of fire, smoke, and toxicity-safe materials, and an early NSRP project that investigated processing improvements to the false deck system. The legacy system had a very iterative and artisan-based installation approach that was quite lengthy and costly. The initial steps taken in this project aligned the disparate designs used on carriers and other surface ships to one requirement set that would work on all surface ships. That alignment enabled a single system that costs less, is easier to install, and will result in less failures in service. The project saved $6.4 million and improved the safety for our warfighters through better system protections and reduced tripping hazards. This last project set is an example of CMTC focusing multiple projects around a similar material solution. CMTC has successfully demonstrated that steel-ready service locker sun shields can be replaced with more rugged and longer-lasting thermoplastic materials. That project will save approximately 8,000 hours of maintenance labor per year. The lessons learned on the Sunshields project are being carried forward to the stowage boxes and drip pans effort. You can see the differences in corrosion resistance of a composite box to a steel box in the lower right picture. We are taking NSWCCD lab scale developments and industrializing them to benefit all surface ships. By pulling out the results highlighted by the previous successful Mantech projects, you can focus your efforts on areas of the ships where composites can make the largest impact. Items that are below the waterline or otherwise failing from corrosion make excellent targets. Additionally, if items are failing from other performance issues such as vibration, mitigating materials can be included inside of the composite system. Items that are curved, or better yet doubly curved, will be less expensive and more repeatable if they are manufactured from composite materials. If something requires high amounts of touch labor, composites, and particularly thermoplastics, lend themselves to automation. Things that impact multiple platforms or weapon systems are also great targets due to the scale of manufacturing. If a steel access door is too heavy for personnel lift, resulting in rigging for routine removal, you should consider a composite solution that will reduce the weight to a single or double person lift. Lastly, if a product uses exotic materials for unique properties, there might also be a composite solution that can eliminate or reduce the amount of exotic materials needed with a hybrid solution. Thank you, and I hope this presentation has given you a better understanding of how composite materials can best be used for ship applications. If you have any questions or great project ideas, please reach out to Nick, Ryan, or myself, or check out our website for other ways to connect.
Hi, I'm Bobby Mashburn, and I'm the Deputy Director for the Naval Shipbuilding and Advanced Manufacturing Center of Excellence, referred to as the Ncm Center. I'll be discussing the Ncm Center over the next few slides and sharing a little bit about who we are and what we do. The Ncm mission is to identify, develop, and deploy advanced manufacturing technologies that will reduce the cost, time to build or repair, and/or increase performance of key Navy platforms. Ncm uses what's referred to as a virtual Center of Excellence model to identify, develop, and execute high-quality process improvement projects. With the virtual COE model, we leverage an extensive network of thousands of industry technology providers and academic institutions to assemble the best team for each unique opportunity. This approach has proven to be successful in identifying significant issues and developing innovative solutions to address those issues. Some of the key aspects of the virtual COE model include teaming with industry experts and the best technology providers, identifying, developing, and executing comprehensive research and development efforts to address critical needs in construction and repair of key Navy platforms, and creating project development, review, and execution teams as needed. The Ncm team consists of an executive director led by Marty Ryan, technical director George Caramico, and a deputy director, myself, Bobby Mashburn. Dedicated contracts and business management personnel led by Skip Solis and Jordan Bush, respectively. 5 project managers, including Warren Sutherland, Tim Macon, Scott Truitt, Sean McDowell, and Mary Kate Moultrie, and a program administrator, Nikki Crosby. The team also includes an extensive resource network and a list of subject matter expertise. Over the past 17 years, using the Virtual Center of Excellence approach, Ncm and the Legacy Center for Naval Shipbuilding Technology has demonstrated a transition rate in excess of 90%. The average return on investment over that period of time is 7.2, resulting in $879 million worth of cost savings for the United States Navy. Total projected cost savings resulting from the implementation of all active and completed projects is close to $2.5 billion over the 30-year shipbuilding plan. Ncm currently has 33 active projects with 9 additional efforts under development. Ncm works closely with ship platform program offices, including PMS 312 for in-service carriers and 378 and 79 for the Ford-class carrier programs. Also work with PMS 400D for the Arleigh Burke-class destroyer program, PMS 450 for the Virginia-class submarine program, and 379 for the Columbia-class submarine program. We continue to work with Joint Program Office for the F-35 Joint Strike Fighter program and Naval Surface Warfare Center Carter Rock Division for assistance with technical support. We also look forward to working with PMS 515 as we continue to work to identify opportunities for the Constellation-class frigate program, FFG 62. Ncm also works closely with prime platform providers and their suppliers, including General Dynamics Electric Boat and Bath Iron Works, Huntington Ingalls Industries, Ingalls Shipbuilding and Newport News Shipbuilding, Lockheed Martin, Northrop Grumman, and Fincantieri Marinette Marine. Due to Ncm's expansive mission, the Center has conducted research and development projects in pretty much every manufacturing discipline, including material handling, spatial scheduling, robotics and automation, improved processing, material and equipment location, outfitting, improved inspection, supply chain optimization, digital process optimization, platform sustainability, product-specific manufacturing improvements, product-specific design changes, among many others, including those that we'll cover over the next few slides. The first Ncm project we'll review is titled Digital Data for Next-Generation Measurement and Location Tools. This project is a multi-platform effort with applicability to both Virginia and Columbia-class submarine programs, as well as the DDG-51 program. This project was conducted with both General Dynamics Bath Iron Works and General Dynamics Electric Boat. The objective of this effort is to improve the processes used to locate and install paint masking and hanger studs through the development of a mobile optical projection device and supporting software to receive and process CAD data and associated product data. The approach used by this effort is the development of a location and work sequencing query software, design and development of a mobile optical projection device and supporting software, development of query data with the mobile optical projection and other location systems, and validation of system accuracy and repeatability. This project is ongoing and expected to wrap up in March 2021. And with applicability to 3 key Navy platforms, it's projected to save over $5 million in the first 5 years following implementation. The next Ncm project is titled Advanced Drilling and Electronic Parameter Transfer, or referred to as the ADEPT project. This is an F-35 focused effort conducted with Lockheed Martin. The objective of this project is the integration of electronic data transfer technologies with automated feed drilling to optimize and automate drilling sequences for varying material stack-ups and hole diameters. The approach used throughout this effort has included advanced drilling technology market investigations, electronic parameter data transfer development, system development and integration, and prototype testing and analysis. This is an ongoing project that's projected to wrap up in March 2022. The projected savings are $6,800 per F-35, resulting in a total savings over 5 years of $3.4 million. The next Ncm project we'll discuss is titled Automated Part Detail Extraction. This is a DDG-51 focused effort conducted with Ingalls Shipbuilding. The objective of this project is to minimize the labor required to manually edit part details coming from ship constructor through the development of a mechanism that automatically dimensions, labels, and supplements parts based on the identified standards from engineering data. The approach used includes examine standards required from producing detailed drawings for fabrication, identify candidate elements that can be electronically extracted in the enterprise toolset, develop a system to automate detail extraction and validation through end-user testing. This project concluded in mid-2017 and has since been implemented. The projected savings from this is $503,000 per DDG, resulting in $2.5 million over 5 years. The next Ncm project we'll discuss is the Digital Thread Shipbuilder Supplier Interface. It's a CVN-focused project conducted with Newport News Shipbuilding. The objective of the project is to improve the material procurement process by extending the digital thread to the shipbuilding supply base and improving first-time quality, cycle times, schedule performance, and supplier readiness. The approach for the effort included the development of 3 key elements, which are simplified technical data packages that provided suppliers with clear, concise requirements that are specific to the material being purchased, 3D design disclosures, which provided suppliers 3D packages that clearly convey design intent and support requirements, secure exchange medium, which established the secure method of two-way data transfer between the shipyard and suppliers. This project, concluded in June 2020, is in the process of implementing and is expected to save $6.8 million per CVN. The next Ncm project we'll discuss is titled Hyperlaser Arc Welding, Process Verification and Implementation for Ship Production. This is a multi-platform applicability effort that was conducted with Ingalls Shipbuilding. The objective of the project was to develop process parameters and conditions for single-sided hyperlaser arc welding, or HLAW butt welds, for various types and thicknesses of steel. HLAW reduces the welding heat input used to join metals, minimizing distortion and reducing rework costs. The approach for this effort included the development and evaluation of process parameters for single-sided HLAW butt welds for thicknesses and material combinations defined in the NAVSEA approved process qualification plan, and the execution of testing that the Navy requires for characterizing performance in sea state operational loading conditions and mission capabilities. This project wrapped up in April 2020 and is implemented at the Ingalls Shipbuilding with the applicability of 3 key Navy platforms. This is a projected savings are in excess of $23 million over the next 5 years. As previously stated, the Ncm mission of identifying, developing, and deploying advanced manufacturing technologies enables a full range of technology development initiatives, including product and process-focused efforts, material development and use, logistics and supply chain projects, IT and admin tools and tracking elements, and advanced manufacturing enterprise projects. We focus on technologies that advance manufacturing processes. We're open to all types of industrial areas, including in the office, in the lab, work cells, on the shop floor, or in platform fabrication. I hope this brief helped to provide a little bit more insight into the Ncm Center. Please feel free to reach out to any of the contacts listed here with any questions. The Ncm website is also provided where additional information can be found about the center or any of our active and completed projects. Thanks so much for your time. Have a great day.
Thank you all for those updates on the Mantech centers. Our final speaker today will be Dr. Justin Retaliata. Dr. Retaliata is the technical warrant holder for additive manufacturing for NAVSEA 05T. Dr. Retaliata has a PhD in systems engineering from George Washington University. He's also DIWEA Level 3 certified in program management and in engineering. Please welcome Dr. Retaliata. Thank you.
Good afternoon, everyone. My name is Justin Retaliata. I'm the tech warrant holder for additive manufacturing. Here to talk to you and give you a kind of an overview of how we're handling additive manufacturing across NAVSEA, and then kind of tie in what we're doing now to how we have leveraged NSRP, and kind of give you guys some ideas of areas we talk about and are concentrating on, so where NSRP can potentially help us as well. So on this slide, we're essentially, these are the levels of effort or lines of effort that we've been working on under the R&D program that is additive manufacturing out of 05. So we have tech authority. What does it take to establish the specs, the standards, the guidelines for getting this equipment, not just the equipment, but also the components, additive components on board our ships. and to kind of get this technology leveraged so that it's helping us in the grand scheme of things. The afloat effort talks through more of the equipment. What kind of equipment are we trying to get shipboard? You know, we have a good understanding how this stuff handles in a lab environment, but when we start shaking, rattling, and rolling it, what are the effects of it? The digital integration, you know, the technology itself is digital, right? So how do we start securing the files and transitioning the files, and where do we store the types of files? Tech data packages, what do we start doing to develop the tech data packages? Reach back support, you know, so how do our engineers reach back and support if the equipment is a forward or deployed or just another shipyard or maintenance center? You know, how do we connect and work with them to move it forward? And then once we have these components, these tech data packages, where supply chain integration. So how do we start getting the additive components into the supply system? How do we start labeling them? How do we start tracking them? And then innovation challenges. So how do we leverage innovation challenges to help push the technology forward? Like, for example, Hack the Machine is one we're doing that's current, where we're looking at our digital enterprise, which I'll talk about in a few slides. How can we hack? How secure is it? How do we hack into it? And then how do we use kind of the grander outreach programs that are innovation challenges to find solutions that we wouldn't necessarily think of inside the bounds of, you know, our government right now. The tech authority products, this is my main swim lane as the tech warrant holder. So I'm supposed to establish the guidelines, the standards for implementing and utilizing the technology and allowing the components that are manufactured that way to be installed shipboard. So the way we're doing this is we released guidance late 2018. We're currently revising it, but this provides the guidelines of how do you get additively manufactured components shipboard? What's the approval chain? What's the reporting chain? As well as what materials in terms of polymer are allowed to be shipboard. This also develops kind of a box without calling it out specifically. If you look on the right, how do we assess the components? So your yellow boxes are the areas where we're triaging and working through. Green box are those low critical parts that, you know, if they fail 100% of the time, it's not the end of the world. But those can be, you know, plastic or metal, but most likely plastic. So things like your knobs, your switches, components or pieces that are below the lowest replaceable unit. So the button on your remote control, for that example. And then your blue boxes, where those are the components that have a structural requirement or a material requirement, or, you know, need to have some pedigree of background data or just manufacturing process to really make sure that that component will hold up under the requirements of the part. And our red boxes are the ones that, you know, it's a good idea, but the technology might not be there, whether it be gaskets or electronics or that type of thing, where you know, technology is working towards there, but it's not necessarily ready for prime time. So that guidance kind of maps out those green and blue boxes, who can sign off for who. So that takes the signature requirements and not only allows, you know, myself as the signature authority, but also provides the delegation authority down to our ship chief engineer, not the ship chief engineers, the waterfront chief engineers, and also the ship chief engineers, if there's capability on board, to sign off on those lower critical parts. Other things we're also working on are technical publications. So these are the qualification requirements for the process. We issued Tech Pub for powder bed fusion last January 2020. And that walks through just what it takes to qualify the machine, traceability of the feedstock and materials, and what you have to do to qualify the first manufacturing production build plate. Moving forward, we have hopefully within the next month or so, we will have the directed energy deposition technical publication out. This is first focusing on wire arc. We will also look into laser wire, laser powder, electron beam wire power sources and feedstocks as well. So this is the first revision of that, or first initial release of that one. We're also looking at what does it take to qualify polymer printers for more critical applications. So where that it can be a polymer part, but there's a structural requirement or that type of thing. So how do we go about assessing machines and then material that come off those machines. Tech data packages, as I mentioned before, are very important. How do we make a tech data package for additive manufacturing? What are the key elements we need to include in it? And then once you start binding all this up and working with the different industry partners and everything, how do we start establishing methodologies so that once we understand the requirements from NAVSEA in terms of tech pubs and what, reporting, the tech data packages, what kind of information we need to know there? How do we start working towards qualifying our vendors for producing additive manufacturing parts? So the specs, the standards, help bound how we manufacture the parts. One of the big efforts under our R&D program is how do we start pushing the technology to the warfighters, to the expeditionary ranges, whether it be afloat or just forward deployed. So as I mentioned before, we kind of have a good understanding how these machines perform in a lab environment. But what happens when you start putting it on platforms that have dynamic situations around them, whether it be sea states or wave slap or just the vibration of being on the ship itself? So what effects did those have, as well as environmental? So temperature swings, humidity swings. What kind of effects does this have on the machines themselves? So over the past few years, we've been working on polymer, installing equipment on about 8 different ships thus far, to just get a good understanding of what are the effects, what kind of use cases come from this when the sailors have this equipment shipboard, and what kind of lessons learned do we find when we start looking at integrating. Snap the chalk line, we've worked through the polymer, with still some things we're learning and working with. Next step is metal AM. So what does it take to integrate metal capability shipboard? So that's part of the overarching R&D project right now that we're working towards, and also working towards what does it take to establish a program of record for additive manufacturing. So right now we're an R&D program, but as this equipment starts getting installed shipboard, what is the logistics tail that is required to enable us to support this equipment once it gets into the sailor's hands, and they need material for feedstock, or they need repair parts, or just overarching support for the machinery. So when we talk to the different capabilities that we're putting shipboard, we've established in the polymer realm tiers, where your tier 1s are your desktop printers, call it kind of your higher grade hobby printers. And these can do your low risk, low critical parts. It comes with the equipment you need to run it, and you can do kind of low grade materials, your PETGs, your ABSs, nylons if required. The next tier is the tier 2, where we start pushing more towards industrial polymer. So these are the ones that can start going towards those critical polymer applications and tie into that technical publication I talked about that we're looking to develop for critical polymers, as well as starts opening up the aperture on what materials we're going to be able to use. So those are your Ultims, your Peaks, your PECs, your carbon fiber infused materials, like the ones that can actually start taking a good structural load. Also increasing the fire smoke toxicity considerations, which is a big part for our additive, getting the additive material shipboard. So, these were established based on lessons learned that we'd had over the past few years of ships installs. Big component of these is how do you get, making sure that all of this kind of equipment can actually be brought onto the ship without cutting a hole in anything. So hatchable is also a very big important player in this equipment selection. So when I talk logistics integration, the beginning of of 2019, we stood up a AM logistics integration team to help us start identifying and figuring out how do we get additive parts into our supply system. So what does it take? What kind of vignettes or challenges do we have? So it can be a make solution, a make or buy solution. So the part can be either manufactured additively or bought through the supply system and procured locally. do you just make it in terms, or make it at point of need, and not worry about supply system? And what are the different kind of challenges that we have run into with this? Also, what kind of part numbers do we assign to these? So, do we assign the NSN numbers to the additive parts? If so, how do we do it? And then how do we start getting it into provisioning and really locking into all the different logistical things that integrate into our supply chain? So this is the engineer talking about logistics, which any logistician will tell you is dangerous. But we're really diving deep and working with the folks that we need to make sure that we have what we need to get this, so that it's not just individual nodes, but we have a supply system that will now support additive manufacturing moving forward. So one of the key parts about that integration into the logistics system is the tech data packages. So this is just kind of a snapshot. This is something that we produced during COVID, early on in the COVID-19 pandemic, towards manufacturing face masks for sailors to manufacture. And this kind of gives you just a snapshot of what the tech data packages consist of. So you have, the signatures and everything on it. You have bill of materials. But on the left, where you see on the red box, there is essentially all the essential elements and attachments that go along with those tech data packages. So maybe the native CAD file, the STL file, potentially the build file, depending on the criticality of the part, and then any of the necessary requirements that go along with those tech data packages. So this gives you essentially the synopsis of being able to manufacture this component repeatedly, regardless of where you're manufacturing it. So if it's being made at, for example, Keyport one day and, Philadelphia the next, we have good trust that that component will be the same regardless of where they're manufacturing. And depending on the criticality of the component, whether it's a green or a blue box, there's other requirements, notes, or quality control type pages and everything. And these tech data packages do revolve around the ASTM requirements and Mill Standard 3100. So it's it's not out on its own, but it's pulling in the specific things that we've been relying on for additive. And as I talked about with the digital aspect of this technology, being able to connect the equipment to our networks is really important, obviously, because otherwise what you're ending up doing is working from a machine that's allowed to hook up to the network, transferring the file onto a removable hard drive, a CD, USB drive, sneaker netting it over to the machine, plugging it into the laptop that runs that machine, downloading it off that, and then trying to get it to the machine, right? So it's very inefficient. Adds a lot of extra steps that we need to do there. So how do we get these computers and these additive machines hooked up to our networks? So what essentially we've established is, and we're beginning to test out, is building a digital manufacturing enclave, where essentially that enclave is where we put our authority to operate. So that establishes the box that we're allowed to plug into, and you get the authority to operate for that enclave. And then that enclave itself plugs into our Navy network. So this is an effort we're actively working right now. We stood up a working group to kind of help guide this between the various digital entities across Navc. And this is also one of the pieces as part of Hack the Machine that we're testing out to see how secure is this enclave and what are kind of the potential issues with it. So those past few slides that I kind of shot in front of everyone talks through overarching high level 50,000 foot view of what we're working on in NAVC for additive manufacturing. So this is to kind of give you a thought process of kind of the focus areas that we're working on. And over the past, so I've been in this job for 5 years. Honestly, we've had NSRP projects since almost the beginning that have been feeding into various aspects of how we do, both on the panel project side as well as the RA side. So early on, we worked with HI and Newport News for developing a framework for using additive manufacturing. So that was areas that help feed into how do we do tech pubs, how do we scope and how do we frame out tech pubs? So that was helping kind of bringing an industry perspective into how we were building our NAVC requirements, right? And that was a partnership across a few NSRP yards. The next is the robotic arc welding, so the directed energy deposition. So this was working with EWI and a bunch of the NSRP yards, and this initial project did butt into a much larger RA project, which is working through this year. And this has actually allowed us an avenue to partner with NSRP and EWI and the performing shipyards along with it to help prove out and find direct applications for our directed energy deposition tech pub. So it gives us opportunities to kind of try as you fly. As we're building these tech pubs, give it some practice, some work, and also gave us avenues to work directly with EWI to help develop some of these tech pubs as well. And the most recent was using, scaling up castings and, using either new technologies such as Meld, or also looking into simulation work that'll allow us to use additive manufacturing and kind of build on it. So these are definitely areas that I welcome folks. If you have ideas, if you have thoughts, areas that you think it could be applicable, and looking kind of at our lines of effort that we're working towards, I'm definitely very receptive and have been very supportive of projects that come across for NSRP. We also had a couple more, I think there were 3 in total, between panel projects and RA projects that were supposed to go through for FY21, expanding upon one of the RA projects here for Meld, and then as well as looking into areas of heat exchangers and using copper nickel to manufacture heat exchangers via additive, as well as helping MSC with additive manufacturing and developing kind of the procedures and everything for MSC in partnership with ABS. So all of these are instrumental in helping bring the technology further, as well as bringing in outside perspectives that are not just internal, right? Because I'm a big believer of we're all going to get there together, and it's not just one single entity or person that's going to be able to do it alone. So at that point, I conclude my slides, and I definitely welcome you to shoot the best questions or any questions you have for me.
Okay, this concludes our first day of the all-panel meeting. I want to direct your attention to the Zoom link email that you've all received from Caroline Mueller. This will tell you the specific links that you need to connect to the panel meetings Tuesday, Wednesday, and Thursday this week. Please refer back to that email for connection. Thank you all for your attention and for your participation today.